Okay, so here we're supposed to find the derivative of f at x for f of x equals 8x minus 2x squared. And again, once we get to doing this, we'll be able to go straight from here to the derivative without having to do all this. But for now, we're going to do it using the difference quotient. So if we do the four-step process, our first step is to find f of x plus h. Okay, well, what we're doing is we're plugging x plus h into this here. So that's going to be 8 times x plus h, and then we're going to take and then minus 2 times x plus h squared. Now we're going to simplify this, and this is why we're doing it in four steps, because we're going to simplify every step along the way to make it a little easier. So to multiply that here, and so that's going to be 8x plus 8h. Now this is going to be x squared plus 2xh plus h squared, and we're multiplying that by a negative 2, so it gives us minus 2x squared minus 4xh, and then minus 2h squared. So that is the first part, just finding f of x plus h. Now, second step, we're going to find the f of x plus h minus f of x. All right, well, what we're going to do basically is we're going to take this and then we're going to subtract off this. So we'll have 8x plus 8h minus 2x squared minus 4xh minus 2h squared. And then we're going to subtract off that, so that becomes minus 8x. Subtract that becomes plus 2x squared. Okay. Now, we're not done because it looks like we can simplify, because this 8x here will cancel that 8x. This 2x squared here will cancel that 2x squared. And that looks like about all we can do. So this then becomes 8h and then minus 4xh and then minus 2h squared. Okay, so that gives us step 2. Now, step 3, we divide by h. So step 3, we have f of x plus h minus f of x all over h, and that equals, now we just say 8h minus 4xh minus 2h squared over h. So we can cancel an h out of everything. So this h cancels that one and one of those. And so that gives us 8 minus 4x minus 2h. And now step 4 said, now we find the limit. So we're going to take the limit as h approaches 0 of 8 minus 4x minus 2h. And when we do that, we just plug in 0 in because it's a polynomial. And when we do that, that goes away and we just get 8 minus 4x. And that's going to be our derivative. Okay? So that then f prime of x equals 8 minus 4x. Now, once we get a little further along, we would be able to get that directly, and we could say, okay, well, when you take the derivative, we decrease this by 1, and so that's a 1 there, so decrease it by 1, it becomes 0, so we just get 8, and then we multiply it by that, and then we bring that 2 times that, and that's going to be a minus 4, delete that by 1, and then we get 4x. And so eventually we'll get there, but right now we have to do it this long pathway. All right. So we're going to use that derivative we just found, and then we're going to do some some problems here with that. So let's write down what we came up with that derivative. So f prime of x we said was 8 minus 4x. Okay. So now we're supposed to find the slope of the graph at 1, 2, and 4. So basically, we're just going to find what f prime of 1, and then maybe we should do it over here, f prime of 2, and f prime of 4 are equal to. Well, if we plug in 1 here, that's going to be 8 minus 4, which is going to be 4. If we plug in 2 here, that's going to be 8 minus 8, which is 0. And if we plug in 4 here, it's going to be 8 minus 16. So that's going to give us a minus 8. So those are the slopes of the graphs at the points 1, 2, and 4. Now, with that said, we're supposed to graph what this looks like and then use the slopes, at 1, 2, and 4 to sketch the lines that are tangent to the graphs at those points. So what we need to do is figure out what this graph looks like first. And if we want to do that, we can plot points. And if we do that, it's going to look something like this. Okay. And so this is at 0, 0, and this is going to be 4, 0. And so what we need to do is we need to figure out where all these points are. So f of 1, so that's 1 here. This is 2 here. This is 3 here. This is 4 here. All right. So at f prime of 1, the derivative, what is that slope? Well, it's going to be a positive, and it's going to be coming up through here, and it's hitting that point, and I can't draw straight lines, so that's about what it looks like there. And that's going to be your slope of the tangent line at that point. Now, when we have a slope of 0, what does that mean? Slope of 0 is a horizontal line. So that means at point 2 here, that's going to be the dot, and we're going to have a horizontal line through there. That was a little bit easier, but still not too straight. And then f of 4 is going to be -8, and so now we're going to be coming down here, and that's going to be our slope at that line at the 4. It's going to be a slope of -8. So that's kind of how we can use our derivatives to figure out what those slopes are going to be. Now, if we would have come over here at 1, and when we plug that in, we ended up with some kind of negative, but we have a positive slope here, we know we've done something wrong with the derivative, or we've done something wrong plugging in the values or something, because if we've drawn the graph right, we should have a positive slope here and 0 slope here, and then down going this way, we should have negative slope. So everything from here this way is going to be negative slope. Everything from here this way is going to be positive slopes, and then this is our 0 slope. So it's going to be really steep, and then it's going to get less steep, less steep, less steep, and then it's going to be 0 slope, and then it's going to get more steep, more steep, more steep, more steep as we keep going down like that. Okay, so that's how the slopes are going to work after we found our derivative. All right, let's stop there and we'll come back with some more problems.